Good afternoon, class. In today's video, what I'd like to do is to go over another problem from the electric field problems. This one will be number 3 on the homework set. So if you want to check that out, you can follow along using that one. This time, what I wanted to do was to finish up this series of videos. I'm going to do this by completing the square. I'm going to solve this problem using the completing the square method. That way, at least you'll have an idea of, or a chance to use either one, a quadratic formula or completing the square. Actually, though, to end this series, what I'm going to do is I'm going to actually show, I'm going to have another video on completing the square and how it connects to the quadratic formula. So I thought I'd kind of show that, but that will be a separate one because that's a lot more generalized. This one is actually an example problem. So I didn't want to, I wanted to just leave this as an example, and then this is the method by which you follow. It's the formula that you can just plug in, and then you can just solve. So if you like completing the square, perfect. If you like quadratic formula, perfect. We can use it either way. So here we go. In the number 3, it says the Q1 is 1 coulomb, Q2 is 3 coulombs, K is 8.99 times 10 to the 9th Newton meter squared per coulomb squared, and our distance of R is 1 meter, just like the other problems. Hopefully what you're starting to notice is that I'm kind of repeating all the same setup for the problem. I'm just changing numbers slightly because all I'm doing, really what I want you to do is just practice. So I hope you're noticing that, especially because I'm trying to keep things about the same, because really what I want you to see is the difference in the approach and how to approach the problems and the math involved in actually solving them. So here we go. Let's actually solve it. Most of this hopefully will look very familiar from the last few videos. We've got our summation. We're going to sum the electric fields, and where the sum of the electric fields is 0. That's going to be where R1 is, which is where R1 is. That's where the electric field is 0. So here we go. We did the same thing set up as last time. We're going to let to the right be positive. We're going to let R2 equal R minus R1. In this case, Q1 and Q2 are not equal. So, so that's something to keep in mind. I think I'll just add that right over here for you. Just as a little aside there, just to make sure that that's very clear. This is not equal in this case. Clearly, they are not. Okay, so what do we do here? We're doing the exact same work that we did last time. KQ1 over R1 squared minus KQ2 over R minus R1 quantity squared equals 0. Our K's cancel. Our Q1 and our Q2 don't cancel in this one because they're not the same, so we actually have to take them into account. So we're going to get the exact same setup as we had last time with the quadratic formula. I've got my A, B, and C terms over here. And so what I'm going to do now is I'm going to go to my completing the square. And in this one, it starts off with a general quadratic formula, ax squared plus bx plus c equals 0. And what you get at the end is this formulation. So what I did, from here I stopped and I said, okay, that's completing the square. I've got my b term, my a term, and my c term. So I'm just going to plug in everything, and we'll just kind of go for it there. So I did that over here, R1 plus, actually I'm not even going to read this because this is quite a lot. I'll let you guys pause the video if you need to, take a look at that, and just go with it from there. So what I did, so in the next step, what I did was I just plugged in all of my numbers. I just followed what I was doing in here. I plugged in all of my numbers with all of their negative signs and everything. So this is a part where I want to pause and maybe point out once again that negative signs are probably one of the things that will screw up your math grade the most. Like they are the bane of all physicists' existence, pretty much. It's negative signs and squares, because that's always the thing that gets forgotten from one line of work to another. And I'm sure you've noticed that too. You'll be working on something and you'll go, oh no, I forgot a negative sign. Oh, I dropped a negative here. And if you think it's not important, it actually is. It's the difference between, in this case, it's the difference between it being between these two to being like way out here. So it's something, you want to consider that, in physical terms, there is actually a consequence to these negative signs, especially if you get them in the wrong place. So I want to make sure I put that out there. Make sure you think about that, because that's something that if you haven't seen it already, you will see it shortly, how much it can really affect the quality of the work that you do when you're doing math problems. So be careful with that. Word to the wise. So I did all of this. I plugged in and all I'm doing is simplifying here. -2 over -2 is +1 over 2 is 1/2. So I had that squared. -2 over -2 is still 1. Square that is 1. 1 over -2 is -1/2, but you're subtracting a negative, so that's why so if you subtract a negative, you're adding. It's essentially saying you're going to add something. So 1 plus 1/2. So then I just took my work, follow the arrow, took my work to the next step. I square rooted all of this because 1 plus 1/2 is just 3 over 2. Then so R1 plus 1/2 is equal to plus or minus square root of 3 over 2. Again, I know I'm skipping a couple of steps, but I did want to save space on the board for that. So then what I did is I subtracted 1/2 because I'm trying to isolate R1. So I subtracted 1/2 from both sides of the equation. So I've got -1/2 plus or minus the square root of 3 over 2. However, I do need to take one more step because I have to determine, is this going to be -1/2 minus square root of 3 over 2, or is it going to be -1/2 plus square root of 3 over 2, or are both answers valid? And the thing is, sometimes it is, especially in gravitational problems, where everything's getting drawn in. Sometimes both answers will actually work, and you'll actually find that. Hopefully I'll have some other videos in the future where I actually have gravity problems that actually do that. But don't worry, those would be a little bit more on the advanced side, so I'm not gonna you don't have to worry about that one too much, at least for the basic level. So then when I did this, I said, okay, so but this negative, if it's negative, -1/2 minus square root of 3 over 2, instead of it being here, it would be somewhere out here. This doesn't make any sense physically. That doesn't work. It has to be in here, so that means that it has to be plus. I have to reject the negative sign. So R1 is going to be -1/2 plus square root of 3 over 2. That will give you, that will tell you how far away it is. And of course, we have to do R2 as well, because we might as well. So it's going to be R minus R1. So when I subtract 1 from this whole thing, I've got 1 minus -1/2, so that's why the positive 1/2. And then of course it's minus this positive, minus the positive square root of 3 over 2, which gives you 1/2 minus square root of 3 over 2 to give you your R2 value. So, so that way, so hopefully that will give you an idea of like where we are. Like this would be the complete answer to this. So in this case, what I'd like to just think about that. So that's the answer to number 3 on the homework set. So, something to think about. If you like doing this completing the square, you might like it when I do my next video on how completing the square and the quadratic formula actually relate to each other. So, check that one out if you're interested. But of course, that's not necessarily a part of these example problems. So that concludes this series on how to do electric field problems, especially answering where the electric field is 0. Good luck in your studies. May the force be with you.